dear learners. Today we are looking at rationalization of numerators of a set. You see, rationalization is not always done with respect to the denominator, but we can also rationalize a set with respect to what? To the numerator, depending on what we want to achieve and what we are doing. You see, this one, the rationalization of numerator of a set becomes more useful and feasible when we are finding the limit of a function in calculus. Now you see, this is normally done to test your understanding of what rationalization actually means, because other students think that when we talk about rationalization, we have to always done it with respect to the denominator. It is not so. So let's look at the steps that we are going to use when we are rationalizing the numerator of a set. In our previous lesson, we learned how to rationalize the denominators of a set, and the steps is the same as that of what the numerator of a set. So let's go through. We just have to make a little changes in the steps. So we said that identify the conjugate of the denominator. That is for the rationalization of denominators of a set. So with the numerator of a set, we just have to identify the conjugate of the numerator. So here is going to be what? Numerator. And then the step 2 says multiply the numerator and denominator by the conjugate of the numerator. And then the step 3 says identify the step 3 says simplify the numerator and denominator where necessary. So the steps is the same as that of the denominator. Okay, the steps is just the same as that. Now let's look at the important note we are going to make use of. So we said that in our previous lesson, we said that a plus b is the conjugate of a minus b. It's still the same here. A plus root of b is the conjugate of a minus root of b. It's still the same here, and we are still going to apply the same concept here. Now the last one that we are going to look at is the property of difference of two squares. It's still the same here, and we are still going to apply these concepts here. Examples. We have example 1. We are to rationalize root of 2 plus 1 all over 4. Root of 2 plus 1 all over 4. So we already know that we first have to identify the conjugate of the numerator. So where is the numerator? This is the numerator. So we have to first identify the conjugate, and we know that the conjugate is going to be root of 2 minus what? 1, and that is what? The conjugate. Apply them. So we are going to get root of 2 plus 1 all over 4, multiply the numerator and the denominator by the conjugate, which is this. So we are going to get root of 2 minus 1 all over root of 2 minus 1. So the last step says simplify where necessary. So let's simplify them. So you can see that we have root of 2 plus 1 times root of 2 minus 1. This is difference of two squares. As we learned in our previous lessons, we just have to square each of the term with the one involving the negative sign. So we are going to square this, and then we square that. So we are going to get root of 2 all squared minus 1 all squared all over 4 times root of 2 minus 1. And we are going to get 2 minus 1 all over 4 bracket root of 2 minus 1. And finally, we are getting 1 out of 4 root of 2 minus 4. And we are done. We have rationalized it. Now, this is actually the final answer. Now, when you rationalize this back, you are going to get this. And when you are doing this, you are rationalizing with respect to what? The denominator. So when you rationalize this with respect to the denominator here, you should get this. And when you rationalize this with respect to the numerator, you should get this. That is how it works. Okay. Now these are very simple. Now let's look at the one that involves the limit of a function. The limit of a function. So let's take it that you have example 2. We are to find the limit of the function root of 4 plus x minus 2 all over x as x approaches what? 0. As x approaches 0. So when you are solving questions under limit of a function, now we have the intuitive approach and then the algebraic approach. Now the algebraic approach, it says that you just have to substitute the value that x is approaching into the function. Now when you do that, you are just going to get what? The limit of the function. But it is not always so, because at times when you do your direct substitution, you are getting what we call the indeterminate form. That is what? 0 over 0. So if that happens, it is telling you that you have to perform some algebraic manipulations in order to achieve what you want. And this calls for rationalization of the numerator. So let's do our normal substitution and see what we are getting. So when you take the limit of this, this is what we refer to as the indeterminate form. The indeterminate form. This is what we don't want to achieve. We don't want to get something like this. So it means that we have to massage the function small. We have to massage the function in order to achieve what we want. So in massaging this function, then it calls for the rationalization of numerator of a set. So we have the limit of the function root of 4 plus x minus 2 all over x as the argument approaches what? 0. So it means that we are to rationalize. So we identify the numerator. This is the numerator, right? Now let's also identify the conjugate. The conjugate of this is going to be what? Root of 4 plus x plus 2, and then we multiply. So we are getting this times the conjugate is 4 plus x plus 2 all over root of 4 plus x plus 2. Good. Now we expand and then simplify. So as I said, we can apply difference of two squares here because we are having these two functions here are difference of two squares. We are having minus, plus, and the terms, the individual terms in each of them are the same. So it means that we square, as I said, when we are having a plus b, a minus b, you simply have to square this and then you square that and then you simplify. You are good to go. So you are going to apply this difference of 2 squared here in order to aid or quicken our calculation. So we are going to get the square of this 4 plus x all squared minus the square of what? 2 all over x out times root of 4 plus x plus 2. Okay, so we know that the square will cancel the radical sign. We are left with 4 plus x minus what? 4 all over x out root of 4 plus x plus 2. But as you are doing, make sure you take the limit. It is very important. You have to add the limit as you are solving. So the limit as x approaches 0. So we can observe that the 4 and the negative 4 will go away, and then we are left with the limit as x approaches 0 of x all over x bracket root of 4 plus x plus 2. So you can see that this and that will also go. So we are left with what? 1. So let's continue it from here. So we are having the limit as x approaches 0 of 1 all over root of 4 plus x plus what? 2. So when you take the limit, you are getting 1 out of root of 4 plus 0 plus 2, and this should give us 1 over root of 4 plus 2, and that is what? 1 out of 4. And this is the limit of the function. This is the limit of the function. Now let's take an example 2. Example 2. We are to find the limit of the function root of x plus 2 minus root of 2 all over x as x approaches what? 0. So let's try. So it means that we are going to apply the same concept. We first have to substitute the value as x is approaching into the function to see what we are getting. This is what we don't want to achieve. So we have to massage the function by applying the concept of what? Rationalization of numerators of a set from here. So we have the limit as x approaches 0 of the function x plus 2 minus root of 2 all over x. So we rationalize the numerator. So we are getting times the conjugate of the numerator, and that is going to be what? X plus 2 plus root of 2. Good, because here is minus, here is going to be what? Plus. So multiply the numerator. So you can see that we have difference of 2 squares. It plays a major role here, applying this concept. So we square this, we square that, and then we are left with. So from here we can see that the x and x will go. 1 out of root of x plus 2 plus root of 2. Now when we take the limit, so you can see that rationalization of numerators of a set plays a major role